Hello and welcome to Intro to Programming. This week we're going to be discussing lists, which are a Python data to store multiple pieces of information in one variable. So far we've discussed a number of types of variables such as integers, floats, and strings, but a list allows us to store many different things inside a single variable and access it very efficiently. We really need lists to do more complicated programs because most programs require us to store more data because there's um, multiple objects that we're dealing with. So that could be multiple let's say students or multiple cars or multiple states or countries or something like that. We need an efficient way to store all these things, and lists are the primary way that it's done in Python. So we'll start by creating lists, and then we'll learn how to access elements within a list and delete elements and a few other things. So a list it's kind of like it sounds. When you have a list of anything, you have a number of items that come one after the other. A shopping list is a list of as many items as you need to buy that are one after the other. And so in Python, uh, the list notation is square brackets. So the simplest possible list is a list that has nothing in it, which is allowed. And that is just a left and a right square bracket. To add items to the list, so this is if we know ahead of time what's going to be in the list, we can declare a list and specify the items, and we can add to it later. So in this second line here, list 1 equals left bracket 1, comma 2, comma 3, comma 4, comma 5. So we have 5 items in this list that happen to be integers. And the final example is a list of strings. So we have 3 strings. Now we don't have to have the same types. We can have a list that has strings, that has integers, that has floats, and that has even other lists and other data structures. We can put anything in a list. Any type of variable we can put into a list. So that's statically creating a list, and I'll show you in PyCharm in a bit. We'll have some examples. So that's statically, meaning we know ahead of time what we want in the list. But a lot of times we don't know ahead of time what we want in the list. We only know as we run the program. But that's okay. We can add lists anytime we want by using the append function, which is, so a list is an object. We've had objects before, such as strings, right? There's, for example, a string function that will convert the string to uppercase letters. And that's string.upper. And in the same fashion, list is a type of object that has functions that we can use. And one of the most important ones is called append. So if we start out with an empty list, so we just say list 1 equals left and right brackets, square brackets, and then we can say list1.append. We'll append the integer 1 to the list, and then we can append another integer. And if we type list1 in our console, it will just print out the contents of the list, which is the integers 1 and 2. So we can append as much as we want, and often that's done in a loop, so that we'll append, let's say the contents of a file into a list or something like that, or we ask the user for input that we'll put into a list. We don't have to put, so when we're modifying a list, we don't have to put each item at the end of it. We can put it anywhere we like. So there's an insert function, and that inserts the function at the index that we specify. Okay, so I should mention what an index is. An index is the way that we find or we note the specific item that's in the list. Okay, so and we'll talk about that a bit more later. But for now, just know that the first item in the list, so in this case, list 1, the first item is 1. The index is 0. Okay, that's maybe a bit confusing, but it is 0. It's not 1. Okay, so just keep that in mind, that we always start at 0, and then we go to the end of the list is the number of elements in the list minus 1. Okay, so if we insert an item at index 0, which is the very first slot, as it were, we put the integer 6 at the very front of the list. Okay, and we can put it anywhere. We can put it anywhere in the middle, or we can put it at the end. Okay, so if we want to have a list that is not static and has many elements, the most common thing to do would be to have a loop to do that. And for loop is a easy way of doing that. So here's an example of, we have an empty list called list 1, and we have a loop in the range of, okay, I guess this one is an example of it not working. Okay, so let me talk to this first. Okay, so we can edit a list by index, but only if that index exists. Okay, so in other words, if we have a list that is has 3 items, okay, so we can say the list with index 0, 1, and 2. If we try to modify the list with an index of 4, then it's going to fail, because 4 doesn't exist, right? There's only 3 elements. So if we try to do something like this little loop here for I in range 1 to 101, and we say list index 1 is I, that's going to fail, because at this point the list doesn't have anything in it. We can only use this notation, list left bracket index right bracket, if there's actually an element with that index number. And if we try to do that, which more than likely you're going to see this at some point in your homework, you're going to get this error, index error, list assignment index out of range. That just means you're trying to access an item in the list that doesn't exist, because the index is correct. So let's do it the correct way of adding a number of items to a list, and that's by using the append function. So remember that append just puts another item at the end of the list and doesn't use the index number. Okay, so in this loop here, list1.append puts the number or the variable I, whatever that is, and at the end of the list. So at the end of this loop here, we're going to have a list that has 100 items, because remember, in the range function is always 1 less than the last number. So from 1 to 100, we're going to have a list that has all those numbers in it. Other ways to initialize lists that have multiple items, we can use the multiplication symbol. It can be used with lists. And what that does is it duplicates, it sort of duplicates what's ever in the list and makes a new list. So if we multiply this list that has one item of 1, variable 1 times 4, we have instead, after this operation, we have 4 elements that is a value of 1. So we have a 2-item list times 2, we just have double that, 2, 3, 2, 3, but within one list. Okay. There's sort of a shortcut if you don't want to use a loop. This is probably a little more advanced way of using loops, but we can use the range function, which generates, remember, numbers between either the index as you specify or between 0 and the end. So in this case, range of 5, it's going to produce numbers 0, 1, 2, 3, 4, and that's going to, the list function, which is actually a function here. Okay, a little confusing. It's a function. It returns a list. We'll use the range function to do that. So let's look at some of this stuff before we get any further here. Okay, so I'm going to call my list L. That's not a 1, it's an L. And here's an empty list. Okay, and let's just append the number 4, and we'll run it, and then we'll go ahead and print the list. Okay. So after I run it, you can see that there's a list here, and we know that because of the brackets, the square brackets. It has one item, which is 4. Okay. So now let's do a for loop. Okay, and then I'm going to append to the list. So the list already has the number 4, but we'll just append I to it. And once again, we'll print it and see what we get. Okay. So now the list has the original 4, and then it has the integers that we added in the loop. So 0 to 9, which is what we get from the range command. Okay. Let's make another list, list 2, and this will be the example of the list, which is a shortcut for doing the same thing, basically. Okay, so list is a function, and what it takes is it either takes it basically takes a function that will generate a list. Okay, and range is a function that will generate numbers. Okay, so I know that's a little bit confusing, but there's certain functions in Python that will generate numbers one after the other, and one of which is range, which we've used. And what you'll see here is L2 will have the same numbers as the original list, except for the 4 at the beginning. Okay. So we print L2 and we get the same thing. Okay. So the point of all this is that there are a number of ways of creating a list that has numbers in it. Okay, without having to necessarily, statically put them all in there, because a lot of the times we don't know what they're going to be ahead of the time. Okay, so once we have a list, the next thing we want to know is how do we access each element in the list? How do we get the information back? Okay, and not surprisingly, it uses the notation of this index. And remember, indexes start at 0 and go to 1 less than the number of items in the list. So here's an example of a list. It has 5 elements, which happen to be states. And the index corresponding to each state is listed on top. And once we have that, we can access each one we want by accessing the index. Okay. So let's go back to our examples and we'll do something like that. Okay. So once again, I'll say list equals, remember we have to append. Okay. Since we don't have those, let's Let's delete all this so we don't get too confused. What's going on here? Okay. So we have an empty list, and now we want to add items to it. So we'll append Okay, I'll just do 3 items. And I'll print it. We'll see what happens. Okay, so you see we have a list which has 3 strings in it. Okay, once we have that, now we can access the individual elements by using this notation. So we have the name of the list and then square brackets and then the index. So we're starting at 0. So what we should see here is the first item in the list, which is Iowa. Okay, let's delete that and let's see what happens here. So sure enough, it prints Iowa. And if we print 2, okay, so this is index 0, index 1, index 2. Okay, so index 2 should get us South Dakota, and it does. And let's see what happens if we put a 3 in there. Then we get this exception. Okay, because there's no item with index 3 because the list is too small to have that number or to have that index number. Okay, another useful thing is that we can access if we want to get the last element of the list, which a lot of times is useful. There's a couple ways of doing this. Okay, and I'll show you. So let's say we want the last item in the list. So what we can do is we can print L, and then we need the index number of the last item. Well, if we don't know how big the list is, or if we don't know offhand how big it is, because it could change, okay, we can use something called the length of the list. So length is a function that will return the size of the list, the number of elements in the list. Okay. I guess before I do that, let's just print the length of the list. Yeah, I think there's something wrong with that line. Whoops, I put a number instead of the name of the list. Okay. So then it prints 3. Okay, so length is another Python function that returns the length of a list. Okay, the number of items in the list. Length also works with strings, by the way. Okay. So the length of that string should be 4. And that's what prints. Okay. Okay, so let's go back to this. If we want the last element in the list, which will be the length of the list minus 1, because the length is always going to be 1 greater than the last index. That's because the indexes start at 0. So that's something that we always have to be aware of. Okay. So minus 1. In theory, that should work. Okay, so this did work, right? So we printed 4, the length of that list. Then we printed the list with the index of length of L, which is 4. or 3 rather, and -1 is 2, which gets us the last element. Okay, so that's one way of getting the last element of the list, but that's actually the hard way of doing it. The easy way of doing it is there's this notation of using minus indexes. Okay, so you might think minus index doesn't make any sense because you start at 0. So what's before 0? Well, nothing is before 0, except that in Python it wraps around to the end. So you just have to kind of think of a list as sort of circular, where you get to the end, you go back to the beginning, and then it makes a little bit more sense. So this is an index of 2, and it also has an index of -1, and -2, and -3. Okay, so if we print -1, we should get South Dakota again, and we do. And -3 should be Iowa. And I'm not sure if you can keep going after that or not. Let's see. Nope, it doesn't like that. So you can only count back to the beginning of the list once. You can't keep going. It doesn't endlessly loop around to let you use any negative number you want. Okay. So let's get an example of instead of getting the elements one at a time, we want to visit all of them, which is very common. Almost always when you have a list, you're going to want to go through the entire list and do something. Like if it's a list of numbers, you might want to add them together. If it's a list of strings, you might want to print them out, or save them to a file, or whatever. Okay. So let's create a list, and then we'll visit every item in the list, and we'll just print out the items. So since we already have a list here, we can have a for loop, and there's several ways of doing this. So let's do it this way, kind of similar to what we learned about getting the last element. Okay, so in this case, we're going to generate numbers that we can use to index the list. Okay. So we want index to go, in this case, from 0 to 1. Okay, so we need to know the last index of the list. So length of L. So it's gonna go from 0 to the length of L is 3. So it's gonna go from 0 to 3. But remember, the range function always returns 1 less than the last number in the range. Okay, so I believe that this will work, and it will print out the items in the list. Let's see. Sure enough, it prints out each item because each time it prints L of the index. So the first number from this loop. So we can go ahead and print that too. But let's print index, and then the item at that index in the list. Okay. So you can see the indexes are 0, 1, 2, and then we use that number to get that corresponding value in the list, and it prints out the states. Okay, so that's one way of doing it. There's actually an easier way of doing it. You can say for state in L, print state. Of course, state is just it's like with any other for loop. you just choose an arbitrary name for that variable. It doesn't have to be state, but since this is a list of states, that's a good variable name because we know what it is, okay? So what this does is for each item in the list, since L is the list, it will assign state to that value, and then you can do whatever you want with it. So we will print the states that way. So here's our first loop, which we had before, which prints the states and the indexes. And the second one, again, prints each state. So that's a very useful way to go through the list and access every element in the list. It's probably the one that I use the most, and probably most people use the most, because you don't have to go through this whole thing of creating a range and then getting the right range for the indexes and so forth. So it's convenient. Okay, so we did those. Okay, another useful thing from strings or from lists is that we can, if we don't want the entire list, we can take a subset of it, and that's called a slice. What a slice does is it returns a subset of the list, but it doesn't affect the original list. Okay, so in the example here, here's a list that has values 5, 1, 6, 4, 8, 9. And these are the indexes. And there's a notation that we have. Instead of just a single index between the brackets, we can have a number and then a colon and then another number. The first number is the first item in the list that you want, and the second one is it's one greater than the last item that you want. So it's like a lot of other things in Python, like the range function, it's one less than the second number, okay? So the notation list one bracket 0:2 is going to get us the elements from 0 to 1, not including 2. And so that list in this example is 5 and 1, okay? So let's see an example of that. Let me get rid of that. And I'm going to add another couple states here just because easier to see some examples. Florida. Okay, so we're going to make a new list, which is a subset of the original list. And let's say it goes from 1 to 3. Okay, just to make it easier here, we'll write these indexes down. Okay, 4. So those are our indexes. So this list is going to go from index 1, which is Illinois, to index 3 minus 1, because it's 1 less. 3 minus 1 is 2. So index 2 is South Dakota. So if we print what we should see is Illinois and South Dakota. And that's what we have, okay? So we can change this to anything. We can go from 2 to as many as 5. Okay, it's 1 more than the last index. Okay. So that's South Dakota, New York, and Florida. Okay, and there's a couple other notations, a couple other tricks that are useful. If you don't specify the second number, okay, so in this example, we have a 3 and a colon, there's no second number, that goes to the end of the list. So however many items are in the list, it's just going to include all of them. And then there's sort of the opposite case. If you don't have the first number in the range before the colon, then it goes from the first item in the list, the 0 index item, all the way up to, in this case, 4 minus 1. So let's check that out. Okay. So let's say we want all the items from 2 to the end of the list. Okay, so we'll just delete that second number, and it goes from South Dakota, New York to Florida. Okay, and if we did a 1 here, it's going to go from Illinois to Florida. So the opposite case is we start at 0 when we go to the end. Okay, so what is this going to be? So there's no number colon 4. Okay, so starting at the beginning of the list, going up to 4 minus 1, which is New York, that's what we should get. Okay, and that's what we have. Now, it's important to remember that this does not change the original list. So we have a new list, which is just, it's a new list, a new variable that has items from the first list, L, but L is still the same. So we don't, it's a non-destructive operation. Okay, so I think we went over those. All right, so I think I'm going to go over one of these. Let's do number 2. It says write a program that asks the user to input a series of integers. If the number is odd, add the item to a list called odds. If it's even, add the item to a list called evens. Exit the loop when the user enters a 0. Previous lists. Okay. We'll delete all this. So we need 2 lists. Okay, one is evens. We don't know how many items are in the list or what those items are, so they have to be empty. So we need a loop, and we don't know when the loop's going to end, so it's going to be a while loop. So we can let's do it this way. We'll say we'll have a loop that won't end until we actually break out of it. So the condition is true, so it will not break out because of this condition. So what we'll have to do is have a break command when we get the right input. Okay. So let's see. We'll say number equals input. What is your number? Okay, and we want to turn that, we don't want that to be an integer so that we can see if it's odd or even. Okay, so if the number and this operator called the Modulo Operator, which I think we've covered that before. If we haven't, what the Modulo Operator does is it returns the remainder from doing a division. Okay, so if you remember from algebra or math class, basically when you divide a 4 by a 3, it goes in one time and there's a remainder. If you divide 4 by 2, it goes in twice and there's no remainder. So if the remainder is, if we divide by 2 and the remainder is 1, then we know that it has to be an odd number. If it's 0, we know that it's an even number. Okay. So if that's, so we do this basic test here. Modulo 2, if it equals 1, we have an odd number. Okay, so then we append to the odds list the number. So it's odds, not odd. Otherwise, if it's not even, it has to be odd. Those are the only possibilities, okay? Okay. And we actually need one more test here so that we can break out of the loop if the number is equal to 0, then we want to break. Remember, break breaks us out of the loop that we're in. Okay. So now we'll print evens, and we'll print odds. All right, let's see if this works. Nope. Okay, that's obviously not the right notation. Try it again. What is your number? We'll say it's 1. It's just going to keep asking me to input things. I'll just put random numbers, whatever I feel like. If I type 0, it should exit. Sure enough, it does. And we have 2 lists. The evens has the even numbers, which you can see 4, 6, 88. Those are all even. Odds 1, 9, 3, 7, 123. Those are all odds. We printed it, and so it all works. So this is a great example of why lists are useful, because we don't know how many items there's going to be, right? That depends on how far the user wants to go. And we don't know what the values are going to be because they come from the user, so they're basically random numbers. But the list allows us to save all that stuff, as many as, there could be essentially an infinite number. But eventually it's going to end. And we can save it all into list, and then probably there would be more processing, like adding up all the even numbers or getting the average or what have you. Okay. So another thing that we frequently want to do when we have a list is we want to find a value in the list, or determine if there's a value that exists. Okay, and there's a couple of pretty easy ways of doing that. We can use the in operator. So we've seen the in before with for loops, where we say for I in range 100, or for item in list. So this is another instance of the in keyword. Okay, and it tells you, it returns true if the value is in a list, and false otherwise. Okay, so let's go back to our program. Yeah, so let's just continue on with this. So we'll continue with that, and then we'll see if certain items are in the list. Okay, so we'll say search value equals, we'll get from the user, what do you want to search for? Okay, and so we'll see if that number is in either one of these lists, right? So if search value in evens okay, let's see if it's in the odds. Otherwise, it doesn't exist in any either list. We'll just say print not found. Okay. So what I'm doing here is, after the user puts items in these lists, then there's a second part of the program that says what number do you want to search for? And then it checks to see if that number is in either one of these lists. So is search value, which is the number, is it in the evens list, is it in the odds list, or is it not found? Okay. So first of all, we put just some random numbers in the list, and 0 says, what number do you want to search for? Well, we know that 6 is one of the numbers because we can see it right there. So we'll say 6. And the response is that it found it in evens, which indeed it is in the evens list. Okay. So that's one way of finding things. Another way of doing it is sometimes it's useful to find the index that something is at. And so lists have something called an index function. And in this case, you pass in again an item in the list and it will return the index, or it raises an exception. Okay, so let's do this one. Okay, so instead of using the in keyword, so instead of saying search value in ins, we say if evens.index search value. Okay, let's do this a little bit different. Okay, so index equals evens.index search value. Okay, so if we find the number, it's going to return that number, and we're going to print index. All right, so let's just, to make it a little simpler here, let's just assume that we're just going to search the evens. We're not going to search the odds. Okay. So let's run this. And we'll just do all even numbers. We won't even care about the odds. Okay, so 0. What number do you want to search for? We'll search for 2 because we know that's in the list. And it printed the index of 2, which is correct because 2 is found at index 0 right here. Okay, that's the index where that was found. Let's do it again, and same thing. We'll go 2, 4, 6, exit the loop, and let's search for a number that's not in there. Okay, 5 is not in there. And so what happened is the way that the index function actually raises an exception if it doesn't find the value in the list. Okay. So the exception is value error, 5 is not in the list. So I believe that the homework last week talked about exceptions. I don't know that I talked about it in the video. So now would be a good time to kind of discuss exceptions. Exceptions are something that happens when there's something unexpected that happens in your program. And we can use exceptions to do error handling, or to make sure that when an error occurs, we respond to it the way the user would want, and instead of just crashing the program. Okay, so we know that there's an exception here. Okay, so what we can do is add an exception handler, which looks like this. So I'm just going to print a message for the time being. Okay. And let's see what happens here. Okay, again, we'll put our numbers. We'll exit. What number do you want to search for? So 6 is not in the list. So what happened is we got an exception like we did before, but this part here the code block that's under the except keyword gets executed, and it prints the message an exception occurred. Okay, so that's not a very good, and in this case, that's not a very good message. We'd want to print something like your number was not found. Okay, so when the number isn't found, then the exception will get raised. You'll catch it, and then you'll do something with it. This is called an exception handler because you should handle the error. You should do something in response to the error. In this case, we'll just say your number was not found. Okay. All right, so we can also delete items from a list. Probably this is going to be used a bit less than some of the other ones. Okay, so I won't go too deep into it, but there's a function called, which is, I guess this is a little bit of an oddball. Because it's not exactly a function. It's a keyword called del, and which stands for delete, and it will delete a particular item in the list. Okay, so we want to delete the item with index 2. Okay, so it doesn't delete the value of 2 from the list. It deletes the item of index 2. So if this is our list 5, 3, 4, 6. So 4 has an index of 2. If we delete that, then we're going to be left with this list. So the delete keyword actually does modify the list. Okay, so after that you delete something, the list is different. Now it's 5, 3, 6. There's a function called pop, which gets rid of the last element in the list. Okay, that is a function, unlike the del keyword. Okay, and then there's something called remove, which takes a value and deletes it. Okay, so if this is our list 0, 8, 9, 2, and we want to remove 8, it's going to modify the list, return a new list that doesn't have the 8 in it. Okay, so there's a number of ways of deleting things depending on sort of what you're after, but deleting things is definitely not as common as either inserting or just, accessing each item in the list. Okay, but let's try the remove function to see how that works here. All right. So I think I'm gonna comment all this out. Don't need that now. Okay, so we'll make a new list, just a simple list which has numbers. Okay. All right, so if we say l.remove 4, okay, and then we'll print l. Let's see. Make sure I get this right. So that, I believe, actually modifies the actual list itself. Okay, it doesn't return a new list. So let's just see what happens here. So we'll print L. All right, so we have this list that has numbers 1, 3, 4, 5. We remove the 4. We print it. Now it's 1, 3, 5. So the list L is actually changed. Yeah. So the list is different. Unlike when you do a slice, it doesn't actually change the original list, but this function remove does, and also delete and pop, they all actually change your list. So if you don't want that to happen, then you need to save a copy of your list so that it doesn't get changed by these functions. one more way, just for fun, there's this notation where we can replace multiple items in a list using the notation that we saw before to access items, but in this case, we're assigning items. So if this is our list, if we say list 0:2 is blank, then it's going to remove 0 and 1 from the list, so it's going to be left with 9 and 2. Okay. But you definitely won't need to use that for any of the homeworks or anything, so we won't go into that. All right, so we talked about a number of functions and methods of dealing with lists. So this little table is useful to kind of summarize that, and you may find this useful for the homework. So we didn't talk about, we talked about some of these, append, insert, length, but some other ones are quite useful, okay? So there's a sort function which will sort your list. Okay, so we can just again, it actually modifies the list, the original list. So we'll put these out of order. Okay, so obviously these are not in numerical order. If we sort it and print it, they should be in numerical order. And they are 1, 3, 4, 5, 100. Okay. Min and max will return the minimum number or the maximum number. That's often useful. Okay. So let's just try that. We'll print min of L. The smallest number is 1, so it should be 1. That's what prints. Max will print the biggest number, which is 100, obviously. Reverse will reverse a list, so whatever, so 1, 2, 3 becomes 3, 2, 1. Count function will count the number of times a value is in a list. Okay, so 5 is in this list 2 times. Okay, I assume it returns 0 if it's not in the list at all. Clear will remove everything from a list. It's probably not all that useful because you can always create an empty list, but it's there if you need it. We talked about append and insert. We talked about length. A useful one is sum. That's something that I think you might be able to take advantage of in the homework. Okay, so the sum of this list is what? It's 105, not 113, it looks like. Okay, so one way to get the sum of a list is you could create a loop, and then you could go through the loop, which you can access each element in the list like we talked about, and then just keep it running total, right? So add the current item to the list and you'll get the sum. This is a shortcut for doing that. Okay. I think we're going to skip that, and I think that we're going to skip, well, I'll briefly talk about two-dimensional lists. So a list can contain another list, right? And so that gives us kind of the, I mean, it basically is a two-dimensional list, right? So if we have something like this, I don't believe that we'll be needing to use two-dimensional lists for anything, but here we have a list that, so this is a list that each element of the list is another list, right? So this is element 0, and it is a list of 3 items. This is element 1, and this is element 2. Okay, so just let's see what we get here. So if we want the first element in this list underscore 2D, okay, index 0, we print that. This is what we get, 0, 1, 2. So we're returning the first item in the list, which happens to be another list. So we can use that to kind of, if you remember from algebra or some other class where you have a 2-dimensional matrix, okay? So the first number is basically the index into the first list, and the second number is the index into the second list. You can think of it as rows and columns, though. If you create a 2D list like this, the first number is the row, and the second number is the column. So let's say we want this number. So it's the third item, which has index 2. Whoops. And then the second column, okay, again, also index 2. So that should print the number 7. Nope. Nope. Again, it's actually 1 less than the number. So I forget that sometimes. So this is index 0, the 6, index 1 and 2. So 2 is actually the 8. So if we want the 7, that's actually in list notation, that's column 1. Okay. So the way to think of this is row 0, row 1, and row 2, and this is, so I guess there's no easy way of doing this. This is column 0, column 1, and column 2. It's not going to line up very well, but I think you get the point here. So this is column 0, column 1, column 2. So with this notation of the two numbers in brackets, we can get at any number from this. Essentially, it's a 2-dimensional array, 2-dimensional matrix, and this would be the way to access that. All right, so we've gone over an hour tonight. That's probably plenty. Okay, I do want to mention one more thing before we leave. Okay, it's not especially important, but there is, I think, some quiz questions related to this, and it may show up on the final, so you should at least have an idea of what it is. A tuple is a list that is immutable. That immutable is the word. It means you can't change it. Okay, there's a section in this document that talks about immutability, and I'm sure that the chapter in the book also discusses it. So tuples are basically just like lists, except a couple things. When you create it with parentheses instead of square brackets, and you cannot modify it. Okay, so you can't add, you can't append to it. You can't insert items, you can't delete items. Okay, so it's basically, it's fixed. Once you have a tuple, you can't modify it. You can create a new tuple, but you can't modify an old one. Okay, so in this example, if we try to change a tuple the way that we tried to change lists with the index notation, it's not going to let us do that. Okay, so let's quickly look at an example here. Okay, so instead of a list, we're going to create a tuple, which we know it's a tuple because it has parentheses. Okay, And so we can do something like print T, the first item in T, that's fine. But if we try to edit this, if we try to say T0 equals whatever, some other number, then we get an exception. It says tuple object does not support item assignment. But other than that, tuples are very similar. We can loop. We can have a loop of a tuple. So we can say for item in T, print item. Okay, so in most ways, a tuple is accessed just like a list. I don't think we'll have any need to deal with tuples in class other than, for the quiz or for if there's something on the final, I don't recall. But you may run across that term, and so it's good to at least have some kind of a notion of what a tuple is. Okay, so that's it for tonight. Since we only had one Zoom, or there's only one Zoom video this week, I may have missed some things that you might want to talk about in more depth. So if that's the case, let me know. Let me know if you have homework questions, and I will help you. So I will say good night and talk to you later.